Welcome to physics.
Hurricane Katrina! More like Hurricane Tortilla.
When the boy reaches for an item on the top shelf of the pantry, he shifts the bag of tortilla chips. This causes the center of gravity of the tortilla chip bag to extend over its area of support, the shelf. The rule for toppling is if the center of gravity is over the area of support, the object will remain upright. However, if the center of gravity extends the area of support, the object will topple. Once the bag falls, it travels at an acceleration of negative 9.8 meters per second squared due to the Earth's gravity. And assuming the shelf height is about 2 meters and the weight of the bag is about 0.5 kilograms, the bag's velocity when the boy catches it can be found by calculating the GPE, greatest potential energy, which is the mass times the gravity times the height, which is 0.5 kilograms times negative 9.8 meters per second squared times 2 meters equals negative 9.8 newtons, which is, when plugged into the kinetic energy formula, gives us a velocity of 6.26 meters per second squared.
This man is able to slide down the hill because the coefficient of friction between his shoes and the ice is so low that friction is no longer affecting him. Therefore, instead of walking down the hill, he can slide. We can actually find the force of kinetic friction on the man traveling down the hill by taking the coefficient of friction of ice and rubber, which is about 0.15 newtons per newton. You multiply this by the normal force, which is the opposite of his weight, times negative 9.8 meters per second squared, which gives you 686 newtons. This gives a force of kinetic friction of about 103 newtons. When the two guys run into each other with yoga balls, they demonstrate Newton's third law, as the guy with the blue yoga ball running into the guy with the gray yoga ball exerts the same force as the guy with the gray yoga ball running into the guy with the blue yoga ball. Newton's law states, for every action, there's an equal and opposite reaction. This means that the size of the force on the first object equals the size of the force on the second object, or what A does to B, B does to A. However, the reason the guy with the blue yoga ball flies back is because he experiences a change in momentum, while the guy with the gray yoga ball does not. Since the guy with the gray yoga ball weighs more than the guy with the blue yoga ball, he stays standing, where the guy with the blue yoga ball falls down because his velocity changes due to the collision with the guy with the gray yoga ball. This clip shows the centrifugal effect. That's the pull that our bodies feel when we're in a centrifuge like this one. The centrifugal effect is caused by the centripetal force pulling towards the center of the circle. However, due to Newton's first law, our bodies want to move in a constant line in a constant speed. That's why the guys had to hold on to the merry-go-round. Otherwise, they would fly off, like the guy in the orange did. He let go because the centripetal force was so strong, giving him such a strong centrifugal effect.
Oh my God.
What y'all finna get into?
Nothing.
Well, let's go to the mall.
Okay.
Alright, I'll drive. Put y'all seatbelts on. Psh, YOLO.
This video demonstrates Newton's first law as the girls are traveling at a constant velocity in the car, and when the car stops, the girl who is not strapped in by the seatbelt flies through the windshield because an object that is in motion stays in motion unless acted upon by an outside net force.
Please tell her to buckle up.
Always buckle up.
Momentum is the quantity of motion of a moving body measured as a product of its mass and velocity. So to calculate the momentum after the kid jumps in the trash can, we use the equation m1 times v1 plus m2 times v2 equals m1 plus m2 times v. Assuming the kid's initial velocity was 1.5 meters per second and his weight is 60 kilograms, and the weight of the trash can is 4 kilograms, the final velocity would be 1.4 meters per second.
You do it.
Bye.
Bye-bye.